Hello and welcome to this video where we're going over one of the issues or one of the solutions I came up with for my open source project Command, where I am working on a raycast/Alfred alternative. With this alternative, I currently already have something going, so you can bring up a command palette, scroll through your list of items, and it scrolls down, and there's support for aliases and stuff, so it's already quite far. But there's one topic that I'm quite interested in. I'm quite happy with the solution, and I wanted to share it with you guys. This solution, and I'm gonna open the Skelly draw as well. Oh, can you stop drawing things? Okay. So the solution I came up with is cross-process and window event buses. So if you look at this, if you click this button, you see this thing lights up on both sides. There are ways to do it within Electron quite easily, but the solution I came up with, I think, is quite ingenious. So what happens is, in the sending window, when I trigger anything on the event bus, it sends an event to the main thread. It doesn't even send it within the window itself. So if you look here back at this thing, if I click it, you see it turn green. That is not happening inside of the window. That's happening still. It's sending an event to the main thread, where after it sends an event to anything that listens to it, which in my case is any window that is created. But also, like here, say any window that's created, but also anything in the main thread listening to it, right? So this is a really simple yet powerful way to send events. And the event bus is super simple. You can trigger, let's jump to the code. You can emit an event, and you can listen to an event, or you can listen once. Listen once isn't used that much. It's used in a couple places, but it's not really used much. But this is all it is, right? And again, this is the type of it, which is in my common package. So let's jump into how it's implemented. So this is roughly how it works. If you want to implement and challenge yourself with the implementation of it, feel free to explore. That's the way how I learned it. I built many Electron apps and all sucked the event system within, because there are ways to listen to events in a window from main process to the window, but you end up with tons of events listening, and this really only has one thing to it. We'll jump into what that means, right? So we have a common package that implements most of the types, and it has some functions in it that rely on those types. But the actual implementation exists in the front and back end. The back end is the main process, so let's jump into this one first. So how it works is, if we go here to utils, we see here the event bus utility, which implements the simple event bus type that we just were looking at. And in here we can see in the event, listen and listen once. This one actually uses the event emitter. Theoretically, I could wrap it in here, but I wanted to add some logging and some more logging in case I need it. A lot of time it's disabled, but if I want to enable for debug purposes, I can enable. But thus far it hasn't broken once, so that's good. But what it basically does is, if I call emit, I need to provide it with a name, right? Which, because it's an event bus, it's a generic implementation. It has one name. And the reason why the name is a constant and I don't allow for name setting is, I want this event bus to be generic. So every event is an event bus event. And so it allows me to listen to it and handle it accordingly. Where the data can allow you to build upon to specify special things, and we'll jump into that in a bit. One of the examples that I can quickly pull up here is the event handler, which uses the event bus in each of the environment. As you see, this is in the common module because this is a generic implementation which is used in both the front and back end. And here you see similar methods, but here you see a bit more specific one. So here you see a type added. This type is here because if I want to have other things using the event bus, I can just specify type, and if the type is not event handler, I can just, I don't know, not process it, as you can see here. And the idea behind the event handler is again, this one is built on top of the event bus and uses the event name to specify the specific event you want to emit and listen. Again, built on top of the event bus, this is a generic solution, right? So if we look back to the event bus, right? So this one on the main thread is fairly simple. You might ask, where is this one used? The generic event bus in the main thread, right? This one is actually used in one location, really. So if we go here to the create window function, this is a generic function that accepts some parameters and allows, does all the window handling for you, where the most interesting thing is the route, which uses it to determine what to display, right? So if we scroll down a bit, excuse me, and we go to the initialize function, one of them is the initialize event bus. This is initialized for every window. This is again how the event bus accepts and emits events from and to every window, right? So the first thing, we check if it's initialized. We stop any existing listeners if they exist. Then we listen. We start listening from event bus, from events from the main event bus. Look back. It listens to the main thread event bus. And if it's triggered, it will emit an event to the window web contents with the name. This is a name for the window. It's event bus from main with the data provided by the event bus. Again, this is a generic implementation. Then we also listen to any IPC events from the web window, which has the action event bus to main. So these are events triggered in the window to communicate. And if we jump back to Skeletor, this is this event basically. So we are listening to events from the window that are sent to the main thread, right? So this is all that we need to do to basically set up the event bus from and to the window. Which, if we can get an event from the window, we basically emit it on against the event bus. And again, doesn't specify anything except the data. Because this is such a generic solution, we can basically build anything on top of the event bus and it will automatically work, right? That's the magic of this one. Now, this is the main thread implementation of the event bus. Again, the main thread handles everything around the events. But we also want to handle it in the windows. And this also needs a generic solution, right? Well, the preloads.ts file here is the, as you can see here, it's located in the main thread. But if we go here to create window, and we go here to the initialize function, and actually we need to go to the open function from memory. No, that is wrong. We need to go to the create browser. Yeah, okay, here. This one loads the preload.js. It's compiled down, but it's basically the preload.ts. In here, we create this is kind of the bridge between Electron and the window front end. If you want to learn more about it, read the documentation. That's the best I can recommend. That's almost all I'm going to say. In here, we basically, as you can see here, also implement the simple event bus, but for the front end. This is the front end event bus. This one is in here because it needs to do all the communication between the window object and the main thread or process. In here, we also need to implement emit, listen, and listen once. And what we're doing here is when we emit, we send an event to the main thread. Again, if we jump back here, this is where we listen to the IPC events, right? So we are listening here, we're sending a event to the main thread. Listening is a bit different because we have here callback. Again, generic solution. There's no way to filter on names in this function itself. So what we're doing here is, there's a bunch of logging here, which by default is disabled. I needed it because I had some issues with it, which ended up not being the event bus, which is great. We set up a handle callback function, which basically calls the callback, which we have provided here. Again, this is for logging purposes. We basically add a listener to the IPC renderer with the event bus from main, which if you go back here, this is basically what the event bus on the main thread triggers against when there's an event on the event bus. And we, let's go back to the preload. We basically handle any event to it, right? Again, also the event bus should always return a disable function. This is really handy in UseEffects in React, for example, if you want to stop listening to certain events when a view is destroyed or whatever. The same happens here. As you can see here, there's an off event for the handle event. And listen once is the same, but we just listen once. So for the other implementation, pretty much the same. And this allows us to basically expose the event bus into the front end. But we don't consume it directly because the event bus is such a generic solution, is not really useful unless you build on top of it, right? So what I've done in both the backend and the front end, so I'm gonna open them both, is, and as I've shown you before, in the backend, there is, if you go to the backend to utils, there's an event handler. This event handler is a generic implementation in the common folder, both used by the front and backend. It expects a event bus, again, both created in the front end and the backend. And what it does, it uses this event bus to then emit events of a specific type and name with data, and emits it against the event bus. Again, generic solution for front and backend, it's all the same. So the data is expected to arrive anywhere correctly. The listen event is mostly the same as the event bus, but the main difference is, and you can see here in the listen event, is we return the listen event because again, it returns the stop listening callback. But it listens to the data we get back, which consists out of the type, the event name that we pass here, and the event data. We check if the type is event handler. I probably should change it to a constant. But it also validates, and again, this builds on top of the event bus, if the current event name is what we expect it to be, right? So if we call listen, we need to pass an event name, which first validates the type and then if the event name is the same, because else we don't really care about the callback. And if it all matches, so again, the type and the event name is the same, then we call the callback. Any other events against the event bus, we simply do not handle. And again, listen once is the same one. It just calls listen once on the event bus, right? So, but this logic is pretty much the same in these two functions. Again, it validates the type and event name. So this is how we can build on top of the event bus. Again, like how you use this one is different. How you want to build on top of this one is different. I build one thing more on top of it, but that's a side story of that's a whole different story. But again, like this is a generic solution, right? So if we go here back in the event handler, we basically call create event handler. We pass our backend event bus to it, and we return it. And we use this one all over the main thread. But also if we go to the front end, we go here, we also have here a similar function. It's a bit different. It's the same implementation. We basically grab the event bus API from the preload, which basically implements the event bus, right? Let me close the correct one. So we go here to the event bus. We basically grab the event bus, which I mean, it's only there on client because there's no window object while compiling Next.js. But we basically grab the event bus and we pass it to create event handler, and we export the event handler, which again in the front end is also used everywhere, right? So this is the quickest explanation I could do around the event bus implementation that I've done. Again, it is a very simple solution. It just sends an event anywhere. It could also be in here. It sends it to the main thread, and the main thread sends it everywhere where it relates to, because it's a generic event bus thing. And in the window, you can listen to it. So if you quickly go back in the windows, you can listen to it, which you can see here, or in other processes again. The main process, handler. I am using this, for example, to handle button click events. Settings being updated, settings being adjusted. A quick example I can give of this is if I go here to this edit window and I remove here, still work in process, that's why it's reloading. But if we open the command palette thingy and I search for FF, because there's no alias for FF currently, it shows nothing. But if I add here FF, you see it appears because suddenly it is there, right? So if I click on it, nothing happens because the flow is not implemented. It's something I'm still working on it, but everything is basically an event in the end of the day. Same here, you can see here the FF alias is there. If I add another alias here, for example, GG, you can see it's automatically being added here. If I remove it all, it also disappears here. Quick flow, I add an exclamation mark, automatically updates here. So it's like it's basically instant because it's inter-process protocol, so it's really quick. So for like usually usage, you barely notice any latency. And also, but yeah, so that's basically what I wanted to go take you guys over with. Hopefully you learned something. Again, if you want to pull down the code and go through it yourself, you can go to this repository. Pull it down locally, go through the code. The code is not the best. I mean, I'm quite happy with the code. It's quite good quality. But yeah, it's probably could have been done better. But again, it's a side project. So thank you guys all so much for watching. Hope you learned a thing or two, and see you next time.